Hi, kgotsong baithuti. Well, we still this is the continuation of electricity basics, but this one is an advanced one. It is actually from the past or the previous examination paper. Same principle. Just be comfortable in your principle and then you continue. And it says what? It says two resistors of 2 ohms, of 20 ohms and 30 ohms are connected in parallel. And this parallel combination is connected in series with a third resistor of a 25 ohm. Now, the whole circuit is then connected across a 50 volt supply. Determine the following: the total resistance of the circuit. The total resistance of the circuit. Let's first draw this. They say two resistors are connected in parallel. And one of them is 20 ohm and the other one is 30 ohm. Now, this parallel combination, this is then connected in series with a third resistor of 25 ohm. This is a resistance of 25 ohm. And then they say the whole circuit is connected across the 50 volt supply. 50 volt supply. This is the total current. The total current will always be supplied by this pressure. This is pressure actually, the voltage. And then here, this total current will divide. Say this is R1, this is R2, meaning this is I2, this is I1, and then this is I3. This I3 should be the same as the total current. This I3 is the same as the total current because this total current is gonna divide there and combine again there at that point and goes to all along and pass through that resistor. So the total current of this circuit is the same as the current through the 3 ohm resistor. But that's not the issue. I was just telling you that. The question is calculate the total resistance of the circuit. For two resistance, not 1, not 3, not 4, not 5, only 2. The formula for calculating the parallel resistance is the same as 20 multiplied by 30 over 20 plus 30 is equal to what? Only for the two resistance. It means only for these ones in parallel, not in series. This is what you can do. Or you can follow the old method of 1 over Rp is equals to 1 over this. Is equals to what? Is equals to 20 times 30. 20 times 30 is 600 divided by 20 plus 30 is 50. Is equals to 12. Is equals to 12 ohm. This 12 ohm is the total resistance of that parallel branch. And to show that you are right, this 12 ohm is smaller than the smallest resistance there. Now, this 12, the total resistance, our total, should be 12 there plus 25. And it's equal to what? It's equal to 37 ohm. Remember, after you connect these ones in parallel, they now form one resistor in series with that one. That's why you add them there. That was the only catch. So the total resistance of this circuit is 37 ohm. And you are done with that part. Now, the current drawn from the supply, there, or actually there, the current drawn by this supply is this current, and it's equal to what? The total current is equal to the supply voltage over the total resistance, and it's equal to what? It is equal to 50 over 37. This is the total resistance, and it's equal to what? It's equal to 50 divided by 37. It's equal to 1,351 ohms. This is the total current of this particular circuit. And you are requested again what? The voltage drop across the 25 ohm resistor. What is the 25 ohm? The voltage drop there. Obviously, in this case, is a combination of series parallel. You first have to find the voltage drop here and subtract this voltage from the total supply, and you'll get a voltage drop there. Either way, it depends. Let's see what we can do. We've got what here? We've got the total resistance of how much there? Of 12 ohm. And we've got a current of what? We've got a current of 1,35, meaning V parallel can be I total multiplied by R parallel, and it is equal to what? It's equal to 1,351 multiplied by 12, and it is equal to what? It's 1,351 multiplied by 12. It's equal to what? 16,212 volts. This is the voltage across this parallel branch. But now, what is the voltage drop there? The voltage drop there, actually, it's 50 minus this, or is the total current multiplied by that thing, that resistance. It's 50 minus 16,212 volts is equal to 50 minus 16,212 volts is equal to what? 33,788 volts, or V series is equal to I3. This I3 is the same as the total current multiplied by the resistance there, multiply by the resistance of the series, which is 1,351 multiplied by 25. This should be the same as that. 1,351 multiplied by 25 is equal to what? Is equal to 33,775 volts. This and that is the same thing. Don't stress about it. That's how you find the voltage drop there. I hope you've been to some over to our home. Oh no, not but to our home this time, Banabaka. Now the voltage drop across that is done. Now they say the voltage drop across the parallel branch. We calculated it already, and it is equal to what? It is equal to 16 there. The voltage drop across the parallel branch. There it is. You can only mention it. It's just that we took an advanced stage. It means there we should have just said I3, which is the total current multiplied by 25 ohm resistor, and then from there we say the total resistance of the parallel branch multiplied by the total resistance. But it's done. It's done. The voltage drop across the parallel branch is there. We calculated it there. And they say what? The current flow across each of the parallel resistors. Remember one important principle. Those parallel branch or those parallel resistors, they operate at the same voltage of what? Of 16,212. That's very, very important. Therefore, it's equals to what? It's equals to, I'm going to erase this one. It's equals to, they say the current flow across each of the parallel branch. The current flow, let's start with I1. I1 is equals to V parallel over R1, which is 16,212. It was calculated there, over R1. R1 is equals to 20. And it's equals to what? 16,212 divided by 20. And it is 0.811 amps. Very, very important units, guys. Otherwise, the whole thing is wrong because we don't know what you have calculated if you don't put units. I2 is equal to what? VP. Why VP? Remember, these two resistors operate at the same voltage. And what is that same voltage? It is calculated at 16,212 from that 50 volt supply. And it's equal to what? It's equals to R2, which is 16,212 over, what is R2? 30. And it's equals to what? It's 16,212 divided by 30. And it's equals to 0.540 amps. Amps. This is the current across each of this parallel branch resistor. And then they say the current flow across the 25 ohm resistor. The voltage drop there is 33 something. It's 33,788. So it's equals to what? The current flow across I3. The current flow across this 25 ohm resistor is V series over R series, which is R3. Let's say R3 rather. Why? It's noted as R3 there. We can say R3 is fine. Then it's equals to what? 33,788 over what? Over 25. A 25 ohm resistor is 33,788 divided by 50. No, sorry, rather. 33,788 divided by 25 is equals to what? Is equals to 1,351 amps. The reason why I calculated it, I didn't want to say the current through the 3 ohm resistor is the same as the total current. You can say that, but I just wanted us to prove our original assertion that the total current here is the same as the total resistor, is the same as the current passing through the 1 ohm resistor. That's why I decided to calculate it, but I should have just mentioned it. I just wanted to make to show to you that actually we are right. Gentlemen, this problem is done, but this is the most difficult problems you will get. But I can only advise, understand the basics, understand the principles, and so on. I don't know how much time I still have more, but I can do another one very fast, I think. This is done. This is done. This is done. If any question, please just drop a comment there. Just drop a comment and tell us, hey, I know with some matzo, but I'm not happy with this and this. We will treat you, or we will make a research for you. See you in the next video. No, not in the video. Let me do another one for you fast before I'm told. I've got 20 minutes on this video rather. They say what? They say, let me check whether, okay, they say from the information given in the circuit diagram. Okay, let's do that circuit diagram. Let's do that circuit diagram. They say, is this, and then is this, and then is this, and then they say is VT, and it's equal to what? They say I1 there is equals to 3. This resistor here is equals to 8 ohm. They say R2 is equals to 4 ohm. They say this current here I2 is equals to 4 amps. And then they say R3 is equals to 2 ohm. And then they say calculate the total current flow. IT is equals to question mark the total resistance of the circuit. RT is equals to question mark, and they say the supply voltage VT. That's basically what is given there. They say from the total, from the information given in this sketch, calculate the total current of the circuit, the total resistance of the circuit, and the supply voltage or the total voltage of the circuit. It's equals to question mark. Please guys, I'm doing this. You must also be familiar with this. I know I'm dealing with grade 11 and grade 12. Most of the time, teachers are hard at work trying to give information and principles. But people say, no, we will study, we don't worry. You won't understand. Grasp at least 70% in class. I'm expecting you to understand this already and say, look, I will grow from strength to strength from here. But don't bother to call or make sure that you find my number anywhere where you can find it. But most importantly, drop a comment so that we can hear what's your problem. I'm normally teaching university information, as you would like to see in the channel, but I was saying please accommodate them. It's exams time, they are struggling, mothers, fathers are looking for tutors. Please take you to do this. So we are accommodating you. Take yourself seriously and your work seriously so that we can take you seriously. Hey, Van Strayer, I never knew you are a philosopher. From this information given, they say calculate this. And what is what? The total current is equal to what? You are given that this is I1, this one, and this one. Remember, in a parallel circuit, the current divide. But here, the total current there is the division of these two current. It means it was the total something and it divides. 3 plus 4 is equals to 7. Meaning here, the total current here is equals to 3 plus 4, which is equals to 7 amps. Which is 7 amps. Why? For those two branches, that current divide into 4 and 3. What does that mean? It was 7 before it branched. That's why it's 7. It's true. Right. They say calculate the total resistance of the circuit. These two are in series. These two. This one and this one. But they are in parallel with that one. Let's first calculate the total resistance for the series connection, and it's equal to what? R series is equal to 4 plus 2, which is equal to 6 ohm. But this 6 ohm is in parallel with the 8 ohm resistor. And I told you now then that this is two resistors. This is a resistor of 6 and a resistor of 8, and it's only 2. You can say the resistance of the parallel branch for 2 circuits is equal to what? 6 times 8 over 6 plus 8. And it's equal to what? 6 times 8, I think, is 48. 48 times 40 is equal to what? Where is that calculator? I don't know whether. Okay, here it is. It says 48 divided by 14 is equal to what? Is equal to 3,429 ohms. Very important units. Ohms. It is the total resistance of the circuit. And then what? They want the total resistance is calculated. They wanted me to calculate the total voltage. The voltage there. V total is equal to the total current multiplied by the total resistance. And the total current is 7 multiplied by the total resistance is 3,429. And it is equal to what? 7 multiplied by 3,429 is equal to what? 24,003 volts. You can say 24 volts. 24,003 volts is the same as 24 volts. And those are your answers, guys. Very nice stuff. We will do the most advanced one. Please, if you've got question papers, bring them and say, look, I want you to treat these problems. We will try. We will make a research for you here. But this is easy stuff. Ladies and gentlemen. But thank you very much. I'm gonna see you in the next video in due course. But I love you all. Shapura.